find the sum of the series, the first thing we notice is that we have the ellipses at the end here, which tells us that this is an infinite series. We do not know how to find the sum unless this is a geometric series, so we're hoping that this is geometric. And to determine the value of r, we ask what we're multiplying by to go from term to term to term, and 40 times r equals 30 tells us that r would equal 3/4. Now let's check. 30 times 3/4 would be 90 over 4, which reduces to 45 over 2, and yes, that does appear to check. The second thing we need to check when we're finding the infinite sums is whether r falls between -1 and +1. And in this case it does, so it passes that test, and it's time to find the sum using the formula s sub infinity equals a1 over 1 minus r. For us, a1 is equal to 40. Divide that by 1 minus 3/4. This becomes 40 divided by 1/4. And whenever you divide by a fraction, you multiply by the reciprocal. 40 times 4 is equal to 160, and that is the sum that this infinite geometric series converges to. Find the 8th term when a1 is 4 and r is 1/4. This is so much easier if you just write this out. The first term is 4. The next term will be 1/4 of that, which is 1, plus 1/4, plus 1/16, plus 1/64, plus 1 over 256, two more terms to go, plus 1 over 1024, plus 1 over 4096. Okay, we need to add all these together. We know the first two terms are going to add up to 5. Let's put the rest of these over a common denominator of 4096. Now, 4 goes into 4096 1024 times. Multiply that by 1 to get 1024. 16 goes in 256 times, so we have 256. And notice the pattern we're going to have in the numerator. It's the denominators from the line above, and then I need the 1 at the end because 1 over 4096 is that last term we're adding on. So here we go. We are going to have 5 plus, and this turns out to become 1365 over 4096. So we could just write this as 5 and 1365 4096ths. Now, there is an alternate way to do this. You do have a choice, and you can use the formula. You can use s sub n is equal to a sub n, or a sub 1, times 1 minus r to the nth power all over 1 minus r. But you're going to have some pretty messy numbers doing it that way also, and there really is no quick and easy way for this problem. You're going to have to deal with those fractions. Write each of these using sigma notation. Well, first off, we're going to have sigma k goes from 1 to the number of terms, and there are 5 terms. And we look at this and we notice that we're subtracting 2. So this is where we're going to go with the formula of sigma of dk plus adjust, which is my little shortcut here. And d is -2, so we will have -2k plus some number such that when we substitute 1 in, we land on the 117. When you substitute 1 in, you get -2 plus 119, which gives you 117 for the first term. Write this next one using sigma notation. Again, we've got 5 terms, so sigma will go from k equals 1 to 5 of, now this is geometric and we're multiplying by a half. For geometric, we're going sigma a1 times r to the k minus first power. So this will be a1, which is 60, times the ratio 1/2, or because there's decimals in here, we could write 0.5, to the k minus first power.